As you watch Digital Works television, you're going to hear something referred to on a regular basis. That would be MBSE, Model-Based Systems Engineering. And to make sure you know what that is, watch this video.
In the past few years, the defense industry has integrated a new way of documenting and developing a product's design lifecycle: model-based systems engineering. You may have heard this term in a class, from a boss, or in conversation with other engineers. It's a modern approach to classic systems engineering principles that leaves paper behind in lieu of creating a dynamic digital model. The model-based approach to systems engineering encourages innovation by enabling engineers to quickly see the effects of changes in the system. This allows creativity and an opportunity to investigate different kinds of questions, or what-ifs, which can be answered with models and help engineers identify and correct errors earlier. Time, scope, and cost can be positively impacted. Systems engineers gather all the moving pieces of a given complex project and put them together to make sure they all fit into the puzzle. For a long time, these pieces have been static documents like PDFs, Word docs, emails, or plain old paperwork. But in the digital age, all of this information can be captured and updated electronically. Now that we've established what model-based systems engineering is, what do these models look like? A digital twin or dynamic model represents an authoritative source of truth for information and design regarding a product. When a change, addition, or any edit is made in a project, it is immediately reflected in real time. Digital model might conjure images of an elaborate 3D model like the Hunger Games arena, where the game makers can add a falling tree or spin the center of the arena in real time with the touch of a finger. But this is a more glamorized and dystopian version. While there are 3D CAD models used in engineering, that is only one type of model. This is ideal for faster and more accurate communication, which enhances innovation. In systems engineering, models are visualized by diagrams made up of different blocks and arrows that illustrate how a complex system is constructed and how the different parts interact with each other. These diagrams can reflect many kinds of information, from object flow to use cases, requirements, specifications, you name it. However, models don't always include a visual or 3D representation of a product. A model is complete when it addresses all of the information the customer needs. What is the problem? What data is available? What output format is needed? When it comes to modeling languages, there are several options. In MBSE, you can use different languages like UML, UPDM, or Systems Modeling Language, also known as SysML, which is most commonly used by systems engineers. SysML is a general-purpose modeling language that specifies and analyzes different complex systems. To build a SysML model, you need a modeling application. Genesis, Rhapsody, and Cameo are all examples of applications that help integrate systems engineering tools. Instead of drawing out block diagrams with pen and paper, SysML allows us to use diagrams to visualize a model. These digital representations can give engineers different types of information about a design by viewing it and interacting with it digitally. You could relate this to real life in a way. For example, say you have taken a trip to Paris and decide to visit the Louvre. Imagine the Louvre is your model. There is only one, so that is your authoritative source of truth, or authoritative source of infamous art. Now, there are many ways you can view the pyramidal-shaped Louvre: up close, far away, above, or from behind. These are all different perspectives of looking at the same model. If you added a star to the apex of the building, kind of like a Christmas tree topper, it would then change the model and be reflected in all relevant views. MBSE has already been adopted by the U.S. Department of Defense and branches of the military. For example, the Department of the Navy's Information Technology magazine, CHIPS, stated, "NAVC is utilizing MBSE practices to keep requirements and design options flexible for as long as possible during the development process. This enables the Navy to simultaneously explore multiple design options in the virtual realm and commit to a technical solution only after validating the assumptions." Although the government has been quick to hop on the MBSE train, industry adoption has been slower. Wait, have we seen this before? Yes, think when CAD made its appearance in the 80s. MBSE is meeting that same sort of initial resistance. Although MBSE is incredibly helpful, it is not a simple fix-all, especially with complex designs. It requires effort to see results. One of the biggest hurdles is that employees will need to be trained in this new approach to design and will need to learn how to use a modeling tool. But the more people are informed about what it is and how to utilize it, the quicker the transition can happen and the more productive and robust our industrial base can become. Digital transformation is coming. The Institute for Digital Enterprise Advancement can help you navigate. IDEA offers professional education courses that upskill current working professionals or students who want to enter the workforce. These courses provide the knowledge and skills needed to be successful at navigating and utilizing MBSE. Interested in learning more? please visit the link in the description. We'd love to hear from you.